Hello guys, welcome back to part 2 on Lewis diagrams and structural diagrams for molecules. So now we're going to go through some tips and strategies and rules for the more complex molecules. And you will get good at this. So we'll take about 10 minutes to do some examples together, and then I'll cut you loose on your assignment. Just going to get rid of my face there. Okay, here we go. So rule number 1, when you're about to build your molecule, you always want to start with the central atom that has the most bonding electrons. So if I look at a molecule that's made of carbon and hydrogen and oxygen and nitrogen. So this fictional molecule, which of these would be the central atom? And the correct answer would be carbon, number 1. 4 bonding electrons. It's always going to form the backbone or the central part of any complex molecule. If carbon was out, what would be your next choice? Most bonding electrons would be nitrogen with 3 bonding electrons. If nitrogen was not part of the molecule, then you'd go to oxygen with 2 bonding electrons, and hydrogen is always going to be a peripheral atom because it has 1 bonding electron. All right, so next rule is symmetry. When you're building these complex molecules and you're looking at the central atom, you want to create a molecule that has symmetry to it. So what does that mean? Well, if I was building water, is it HHO or HOH? Which of those has symmetry? So symmetry means if I split it down the middle and looked at the left and the right side, a symmetrical molecule would have the same shape or balance or atoms on both sides. So this would be symmetrical, and this one would not be symmetrical. So this is the better choice for building water, which means 2 lone pairs, 2 bonding electrons. I would put 1 hydrogen on each side, and the molecule would be symmetrical. The left and right side would look the same. So that would be the best choice for water. When you have extra bonding electrons left over on either peripheral atoms or central atoms, and they do not have a full octet, then you are making double bonds or triple bonds, depending on how many bonding electrons are left. So a good example of this is HNO. And we can tell here that they're giving us a hint to put nitrogen in the middle. And that also makes sense because nitrogen has 3 bonding electrons. It's got the most. So hydrogen on one side, that bond is done. Nitrogen still has 2 bonding electrons left. And oxygen, I'm going to put its lone pairs to the outside and its 2 bonding pairs neighboring nitrogen, so we can make that first bond. Now, if you look at oxygen, it only has a total of 7 in its valence, and nitrogen also has 7 in its valence. Whoops, I didn't get that right. 2, 4, 6, 7, and 2, 4, 6, 7. So how do we get 8 for both of them? Swing the last bonding electron of each atom to the center to make a double bond. So what would this look like? So here was our first bond between oxygen and nitrogen. And I took that second bonding electron on each of these and swung them to the center to make a double bond. And now nitrogen has 2, 4, 6, 8 valence electrons, and oxygen also has 8. So it's a stable or a full octet for both. And as a structural diagram, it would look like this. Single bonded H to the N and a double bonded nitrogen to oxygen. And my last hint is that sometimes when you have very large complex molecules, the formula gives you a hint as to how to structure the molecule or how to attach the atoms in order. So this molecule has carbons in the center, and oxygens, 2 oxygens, and a hydrogen on the outside. So I am going to put an oxygen bonded there with one more bonding electron and its 2 lone pairs bonded to a hydrogen. So the hydrogen is on the outside, hydrogen is on the outside. And then I have 2 bonding electrons left for the other oxygen, and that works because the other oxygen has 2 lone pairs and 2 bonding electrons to make a double bond. And it would be the exact same thing on this side, 2 lone pairs and 2 bonding electrons for a double, and an oxygen with 2 lone pairs, a bonding electron, and 1 more bonding electron for the remaining hydrogen. I'm going to clean this up in a structural diagram, C double bond O, O, H, with another carbon in the center. So I've got my 2 central carbons and everything radiating out, C double bond O, O, H. This is one of the hardest ones to figure out and draw, so my advice would be when you see this, you just immediately jump to this, C double bond O, O, H, with 1 bond left over for whatever's coming off of this side. Okay. So now that you have those hints, let's do the more complex molecules. This won't take long. We'll work through them one at a time. As I said earlier, at first they're hard, and as you do more of them, you'll get better at them, and we've got a whole bunch of practice sheets for these. So CH3OH, again, I'm getting a hint here that it's a C with 3 hydrogens hanging off of it. So there's my carbon with my 4 bonding electrons. Hydrogen number 1, hydrogen number 2, hydrogen number 3, and then the 4th bonding electron must be for this oxygen. 2 lone pairs, 1 bonding electron, and a second. So where do I put this H? Hanging off of this last oxygen right there. So there's my bond, and a lone pair, a lone pair. As a structural diagram, C, H, 3, O, H. And again, that fits the formula of CH3 bonded to an O, bonded to an H. Okay, pH3. Phosphorus has 3 bonding electrons, so it goes in the center. Each hydrogen has 1. That's a nice easy one. pH3. CO2. So we have carbon and oxygen. Carbon has 4 bonding electrons. Each of the oxygens only has 2. So here's an oxygen atom with its 2 bonding electrons. You can kind of see where this is going to go if you make a prediction. We've got 2 bonding electrons for each of the oxygens. And carbon has 4. So that means 2 of these can share with 2 of carbons, and then the other 2 will share orbitals with those. So what's this going to look like? Oxygen will share its 2 bonding electrons with carbon's 2 bonding electrons, and then here's its 2 lone pairs. So a lone pair and a lone pair, and this is our double bond. Same thing on the other side. Oxygen's 2 bonding electrons are used to make a double bond, and its 2 lone pairs sitting like that. I draw this out as a structural diagram, C double bond O, C double bond O. Hopefully you're starting to feel better about these. Okay, N2H2. Nitrogen has 3 bonding electrons from group 15, 5 valence, a lone pair, 3 bonds. Now, think about our symmetry rule. Would I go N, N, H, H when I build this? Or would I go N, N and put an H on each side? Which of these split down the middle gives me the better symmetry? And secondly, I want the most bonding electrons in the central atoms. Nitrogen has the most, so it should go central. So nitrogen, nitrogen linked to each other, and now I've got 2 bonding electrons left on each nitrogen, but I only have a total of 2 hydrogens. So I can put 1 hydrogen on each side, overlap the orbital, 1 hydrogen, overlap. What do I do with these guys? They're leftovers. I swing them to the middle to fill my octets and give each nitrogen access to 8 electrons. So I'll just clean this one up. Nitrogen bonded to nitrogen, each with a lone pair. Each of them bonded to a hydrogen. And 1 more bond to give us a double bond. And if we count any one nitrogen, it has 8 valence electrons in its octet. And the same with the other nitrogen has 8. Structural diagram, N double bond N H. H. Okay. We're getting close. What do we have left here? 1, 2, 3 left. Okay. C3H8. Carbon has the most bonding electrons, so those will be your central atoms. Carbon bonded to a carbon, bonded to a carbon. Okay, so I've used up 1 bonding electron from each carbon to tie them together. I have 8 hydrogens left, and you'll notice that I have 8 bonding electrons left. 1, 2, 3, 4, 5, 6, 7, and 8. There we go. And as a structural diagram, six, 7, 8. And hopefully you know the common name for C3H8, propane. And after doing all of this work on these diagrams, you might think of it more as propane. Haha. Okay. HCN. So carbon is our central atom. This is telling you that, and carbon has 4 bonding electrons. 1, 2, 3, 4. Hydrogen has 1. So there we go. Carbon still has 3 left, and nitrogen has 1, 2, 3 as well. So make a prediction. What's going to happen with the remaining 2 bonding electrons from carbon and nitrogen? What do we do with remaining electrons, bonding electrons? We swing them interior to make multiple bonds. So swing these guys in, swing these in, and we get C triple bonded to N, and hydrogen sitting right there, and nitrogen's lone pair. So now this carbon has access to 8, and nitrogen has access to 8, so they're both stable. And as a structural diagram, looks like that. Okay, take a breath. We're on our last one. CH3COOH. And again, here's one where it's very helpful to see the structural arrangement. Carbon bonded to 3 hydrogens, bonded to a carbon, to a C, to an OOH. And remember that COOH is going to be this. So we have a CH3, H1, H2, H3. There's our CH3. And this carbon is bonded to this carbon. There we go. Done. 3 bonding electrons left. These 2 are going to be used to bond with oxygen's 2 bonding electrons to make a double bond. And this last bonding electron will bond to one of oxygens, and the second one bonds with the H. As a structural diagram, CH, 3, C, double bond O, O, H. That's pretty much everything you need to know. To practice these, you will need to go to your study guide, pages 118 to 120. And so that's 3 pages. I'm posting the answers online on Google Classroom for you to check. And I suggest you check after every 2 or 3 to make sure you're getting them right. As you do more and more of these, it gets easier. And by the time you're on to page 120 or the 3rd page, you should be getting good at these. And there's also some challenging ones on that page for you to practice as well. If you want to read a little more in your textbook, you can look at page 88, 89. It also shows you another method of counting electrons, but I think that's a little tricky, and I think if you use the approach I showed you today, you'll have success. Okay, good luck, everybody.